Our topic for today is all about arithmetic series, and your task will be find the sum of the terms of a given arithmetic sequence. To find the sum of an arithmetic sequence, we can use the formula S of n is equal to n over 2 times the quantity of twice the first term plus the quantity of n minus 1 times the common difference. This is commonly used when the last term is not given. If the last term is given, we can use the formula S of n is equal to n over 2 times the quantity of the first term plus the last term. Examples. Number 1. Find the sum of the first 10 terms of an arithmetic sequence 5, 9, 13, 17, and so on. Since the last term is not given, we will use the formula S of n is equal to n over 2 times the quantity of twice the first term plus the quantity of n minus 1 times the common difference. In this given, since we are looking for the sum of the first 10 terms, the first term is 5 and the common difference is 4 and n is 10. So by substitution, we have S of 10 is equal to 10 over 2 times the quantity of 2 times 5 plus the quantity of 10 minus 1 times 4. And 10 over 2 is 5, and 2 times 5 is 10, and 9 times 4 is 36. So 10 plus 36 is 46, and 5 times 46 is 230. Therefore, the sum of the first 10 terms of the arithmetic sequence 5, 9, 13, 17 is 230. Number 2 example. Find the sum of the first 12 terms of a sequence whose first term is 3 and the last term is 43. Since the first and the last terms are both given, we can use the formula S of n is equal to n over 2 times the quantity of the first term plus the last term. Since we are looking for the sum of the first 12 terms, n is equal to 12, and the first term is 3 and the last term is 43. So 12 over 2 is 6, while 3 plus 43 is 46. So 6 times 46 is equal to 276. Therefore, 276 is the sum of the first 12 terms of a sequence whose first term is 3 and the last term is 43. Find the sum of each sequence. Number 1, 35 plus 32 plus 29 plus 26. Number 2, negative 34 plus negative 64 plus negative 94 plus negative 124. Number 3, negative 30 plus negative 40 plus negative 50 plus negative 60. Number 4, 9 plus 14 plus 19 plus 24. And the last number is negative 7 plus negative 9 plus negative 11 plus negative 13. The sum for number 1 is 122. Number 2 is negative 316. Number 3 is negative 180. Number 4 is 66. And number 5 is negative 40. Now, let's have another task. Give what is required. Given the sequence 3, 7, 11, 15, 19, and so on, what is the common difference? What is the sum of the first 4 terms? What is the 50th term of the given sequence? How about the sum of the first 50 term? The common difference of the given sequence is 4. We have 7 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4, and 19 minus 15 is 4. What is the sum of the first 4 terms? That is 3 plus 7 plus 11 plus 15 is equal to 36, or 4 over 2 times 3 plus 15. And since we are looking for the first 4 terms, so that is 2 times 18 is equal to 36. By using the formula, a sub n is equal to the first term plus the quantity of n minus 1 times the common difference, the 50th term is equal to 3 plus 49 times 4, which is equal to 3 plus 196, and that is equal to 199. Therefore, the 50th term of the given sequence is 199. And to look for the sum of the first 50 terms, we will use the formula S of n is equal to n over 2 times the quantity of the first term plus the last term. Since the first term is 3 and the last term is 199 and n is 50, we have S of 50 is equal to 50 over 2 times the quantity of 3 plus 199, that is equal to 25 times 202, which is equal to 5050. Therefore, the sum of the first 50 terms of the given sequence 3, 7, 11, 15, 19, and so on is equal to 5050. Let's have more. Let's add the known to the unknown terms. Find the sum of the terms in the arithmetic sequence for the number of terms indicated. Number 1. Find the sum of the first 30 terms of 4 plus 1 plus negative 2 plus negative 5 and so on. Number 2. Find the sum of the first 25 terms of 6 plus 12 plus 18 plus 24 and so on. Number 3. Find the sum of the first 15 terms of the given sequence 10 plus 7 plus 4 plus 1 and so on. Number 4. Find the sum of the first 40 terms of 13 plus 12 plus 11 and so on. And number 5. Find the sum of the first 35 terms of the given 2 plus 9 plus 16 plus 23 and so on. Since the last term is not given, we will use the formula S of n is equal to n over 2 times the quantity of twice the first term plus the quantity of n minus 1 times the common difference, where n is 30, first term is 4, and the common difference is negative 3. By substitution, we have 30 over 2 times the quantity of 2 times 4 plus 30 minus 1 times negative 3. 30 over 2 is 15, 2 times 4 is 8, and 29 times negative 3 is negative 87. So we have 15 times 8 minus 87, which is equal to negative 1185. Or we can solve this using the other formula. Since the other formula is S of n is equal to n over 2 times the quantity of the first term plus the last term, we will get the last term first. So the last term will be negative 83. We have 30 over 2 times 4, which is the first term, plus the last term, which is equal to negative 83. So we have 30 over 2 is 15, while 4 minus 83 is negative 79. So S of 30 is equal to negative 1185. Number 2. The sum of the first 25 terms of the given sequence 6, 12, 18, 24, and so on can be solved using the formula S of n is equal to n over 2 times the quantity of twice the first term plus the quantity of n minus 1 times the common difference, where n is 25, first term is 6, and the common difference is 6. By substitution, we have 25 over 2 times 12 plus 144, and the sum of the first 25 terms is equal to 25 times 78, which is equal to 1950. Or if we want to use the other formula, we still need to get the last term, which is the 25th term. To be able to get the 25th term, we will use the formula A sub n is equal to the first term plus the quantity of n minus 1 times the common difference, wherein the first term is 6 and the common difference is 6. So we have 6 plus 24 times 6 is equal to 6 plus 144, which is equal to 150. Therefore, the 25th term of the given sequence is 150. By substitution, we have 25 over 2 times 6 plus 150, which is equal to 156 times 25 over 2. So 25 times 78 is still 1950. We can use either of the formula to solve for the sum of the given sequence. Number 3, we can find the sum of the first 15 terms of the given sequence 10, 7, 4, 1, and so on by using the formula S of n is equal to n over 2 times the quantity of twice the first term plus the quantity of n minus 1 times the common difference, where n is 15, first term is 10, and the common difference is negative 3. So by substitution, we have 15 over 2 times the quantity of 2 times 10 plus 15 minus 1 times negative 3. So we have 15 over 2 times 20 plus 14 times negative 3. And we have 15 over 2 times 20 minus 42, which is equal to 15 times negative 11, and that is equal to negative 165. Or, by using the other formula, we will first get the 15 terms of the given sequence, 10, 7, 4, 1, and so on. So we have 10 plus the quantity of 15 minus 1 times negative 3, which is equal to 10 plus 14 times negative 3, and that is 10 minus 42. So the 15th term of the given sequence, 10, 7, 4, 1, and so on, is negative 32. And by using the other formula, we have 15 over 2 times 10 minus 32, which is equal to 15 times negative 11, which is equal to negative 165. Number 4, we will look for the sum of the first 40 terms of the given sequence 13, 12, 11, and so on. The first term is 13, the common difference is negative 1, and n is 40. So by substitution, S of 40, or the sum of the first 40 terms of the given sequence 13, 12, 11, and so on, is negative 260. Even if we use the other formula, which is S of n is equal to n over 2 times the quantity of the first term plus the last term, the value, or the sum of the given sequence, is still negative 260. So, the choice of the formula that you will use is yours. Number 5. The sum of the first 35 terms of the given sequence 2, 9, 16, 23, and so on, wherein the first term is 2, n is 35, and the common difference is 7, is equal to 4,235. We hope you learned